Hi friends, good morning. Welcome to Civtech Simplified. I am again with you with structural analysis part 8. Here I will also present 25 multiple choice questions which would definitely help you for preparing for your next exam. In this lecture, we have included questions which are mostly coming in the exams, and these would help civil engineers like you to prepare for any sort of the competitive exams, job interviews, and university tests. And remember, the correct answers have been highlighted as previous over here. So let's get started with today's video. It's part 8. So question number 176. Deflection equations method was developed by. Who developed the deflection equation method? Option A, Mohr. Option B, Bernoulli. Option C, Maxwell. Option C, Mohr and Mandrella. Question is about deflection equation method was developed by. Option A is Mohr. Option B is Bernoulli. Option C is Maxwell. Option D is Mohr and Mandrella. So D is the correct option. The deflection equation method was developed by Mohr and Mandrella. Question number 177. First step in displacement method is to find stiffness coefficient. State whether the above statement is true or false. The first step in displacement method is to find stiffness coefficient. State whether the above statement is true or false. So we know that this statement is false. So B is the correct option for this question. A was true while the option B is false. So B is the correct option over here. Question number 178. What is SI unit for stiffness coefficient? Option A, meter per kilonewton. Option B, kilonewton per meter. Option C, kilonewton. Option D, meter. So B is the correct option for this question. It's kilonewton per meter. The SI unit for stiffness coefficient is kilonewton per meter. Question 179. Which of the following is unknown in displacement method? Which of the following is unknown in displacement method? Option A, force. Option B, displacement. Option C, sport reactions. Option D, cannot say. So A and B, force and displacement, are unknown in the displacement method. Question number 180. For the validity of principle of superposition, materials should behave in which manner? Question 180. For the validity of principle of superposition, materials should behave in which manner? Option A, linear elastic. Option B, non-linear elastic. Option C, non-linear inelastic. Option D, linear inelastic. So yes, D is the correct option. The material should behave as linear and inelastic for the validity of principle of superposition. So D here is the correct answer for this question. Question 181. How many rotations are possible in case of three-dimensional frame or beam? How many rotations are possible in case of three-dimensional frames or beams? Option A, 1. Option B, 2. Option C is 3. Option D is 4. So yes, 3 rotations are possible in case of three-dimensional frame or beam. Question 182. How many linear displacements can a node have in a two-dimensional frame or beam? Yeah, of course, it's 2. So A is the correct. A is option. Option A is 1. Option B is 2. Option C is 3. Option D is 4. So in case of two-dimensional frame or beam, there are two displacements, linear displacements. Question 183. Which of the following methods for solving indeterminate structures are easiest for computational purposes? Which of the following methods for solving indeterminate structures are easiest for computational purposes? Option A, force method. Option B, displacement method. Option C, method of consistent deformation. Option D, moment or area method. So B is the correct option. It's displacement method. For the following methods for solving indeterminate structure, which is the easiest method? It's displacement method. So B is the displacement method. So and this method is the easiest one with respect to the computational purposes. 184. While using slope deflection method, in which direction is moment taken as positive? In which direction the moment is taken as positive? Option A is clockwise. Option B is anti-clockwise. Option C depends upon case. Option D depends upon loading. So in case of slope deflection method, the moment taken in clockwise direction is taken as positive, while in anti-clockwise it is taken as negative. So A here is the correct option, which is clockwise. Question 185. A and beam are fixed supports. A and B are fixed supports. If support B settles by 1 mm downward, what is the direction of rotation at point A? So it's setting at downward, it's clockwise. So A is the correct option. A is positive, B is negative, C can't say, D depends upon loading at point A. So A here is the correct option, which is positive. The direction of rotation at point A would be positive. A. 186. A and B are fixed supports. If support B settles 1 mm downward, what is the direction of rotation at point B? So option A is positive, option B is negative, option C can't say, option D depends upon loading at point A. So in case of A and B supports, fixed supports, if B settles downward, then the direction of rotation at the same point is also positive. A is the correct answer for this question. 187. If a beam has 4 external supports, then how many parts would be divided in case of using slope deflection method? 4 beams, so 3 parts. Option A is 0, option B is 1, option C is 2, option D is 3. So 3 is the correct answer, D. 188. How many SDE slope deflection equations are possible if 4 supports are there? How many slope deflection equations are possible if 4 supports are there? Option A is 0, option B is 3, option C is 4, option D is 6. So yes, D is the correct option for this question, 6. 6 supports are possible in case of in case of slope deflection. 6 slope deflection equations are possible in case of 4 supports. 189. To convert indeterminate structure to a determinate structure, number of force release to be provided equals to number of force released to be provided equals to option A, number of equilibrium equations for respective structures available. Option B, external static indeterminacy only. Option C, internal static indeterminacy only. Option D, static indeterminacy. To convert indeterminate structure into a determinate structure, Number of force reaction to be provided equals to static indeterminacy. So D here is the correct answer. Question 190. Static indeterminacy for pin jointed plane frame is given by static indeterminacy for pin jointed plane frame is given by option A m plus r minus 2j, option B m plus r minus 3j, option C 3m plus r minus 3j, and option D 6m plus r minus 6j. So static indeterminacy for pin jointed frame is given by option A is the correct answer, which is m plus r minus 2j. Question 191. When a structural member of the uniform section is subjected to a moment at one end only, then the moment required so as to rotate that end to produce a unit slope is called. What is that moment to produce unit slope? Option A, resistance of member, option B, stiffness of member, option C, capacity of member, and option D, potential of member. So yes, that moment is called stiffness of the member. So B here is the correct answer for this question. 192. Muller-Breslau principle gives a quantitative analysis of indeterminate structures. Option A, B, true. Option B is false. So yes, it's the false. So B here is the correct answer. 193. In BMD, bending moment diagram and shear force diagram, option A, points remain fixed, position of load changes. Option B, points changes, position of loads remain fixed. Option C, both of them changes. Option D, neither of them changes. So in case of bending moment and shear force diagram, points changes while position of loads remain the same. So B here is the correct answer. 194. In influence line diagram ILD, option A, points remain fixed while position of load changes. Option B, points changes, position of load remains same. Option C, both of them changes. Option D, neither of them changes. So in case of influence line diagram, A is the correct option. That is, points remain fixed while position of the load changes. A is the correct answer for this question. Question 195. For drawing ILD, what value of test load is assumed? Option A, 1 unit. Option B, arbitrary. Option C, depends upon structure. And option D is 0. So for drawing ILD, what value of test load is assumed? That is unit load, 1 unit. So A is the correct answer. 195. ILD of statically determinate beam consists of curve as well as straight line. State whether the above statement is true or false. A is true, B is false. Yes, this statement is false. So B here is the correct answer for this question. 197. Maximum point of ILD always lies at the point at which load is applied. State whether this statement is true or false. Yes, it is true. It is false. Maximum point of ILD always lies at point at which load is applied. So this is false statement. B here the correct answer. 198. Floor loads are transmitted from slabs to which part in a floor girder system? Floor loads are transmitted from slabs to which part in a floor girder system? Option A, floor beams. Option B, side girders. Option C, supporting columns. Option D, nowhere. So yes, the floor loads transmitted on the floor beams. A is the correct answer for this question. Floor loads are transmitted from slabs to the floor beams. 199. For a cantilevered beam, where would absolute maximum shear occur? For a cantilevered beam, where would absolute maximum shear occur? Option A, at midpoint. Option B, depends upon position of load applied. Option C, just next to free end. And option D is just next to fixed support. So for a cantilever beam, where would absolute maximum shear occur? It will occur at just next to the fixed slope. So D here is the correct answer for this question. In case of cantilevered beam, uh, the maximum shear occurs just next to the fixed support. D is the correct answer. Question number 200 and the last question for this video part. For a simply supported beam, where would absolute maximum shear occur? For a simply supported beam, where would absolute maximum shear occur? The earlier question was about cantilever beam, and option A here is at midpoint. Option B depends upon position of load applied, and option C just next to one of the ends, and option D at both of the ends. So for a simply supported beam, where would absolute maximum shear occur? It's option C, just next to one of the ends. In case of simply supported beam, the absolute maximum shear occurs just next to any one of the ends. So C here is the correct answer for this question. So thank you for watching this video part. We have so far completed 8 parts under structural analysis. And we request again to subscribe to Civtech Simplified and follow us on Facebook, Instagram, as well as TikTok. Thank you.